Today is the final exam review session. And so, pretty much I'll let you know all the information I know about the final exam, besides for, of course, the exact questions on them. And so one thing I want you to notice is in MyMathLab, under course documents, there is the final exam answer sheet. So when you click on that, this is the answer sheet. I think I mentioned it before, but you're going to go ahead and, if you can, the most convenient thing would be to print this out. But if you can't, then you would need to write down on loose leaf paper just placeholders for each one of these. So problem 1, problems 2 and 3, all that stuff. So this is going to be your scratch work, or your main scratch work for the final exam. And once you're done writing down everything on your scratch work, this is what you will be submitting to me as one continuous PDF file, as if it were a workbook assignment. You submit it as one continuous PDF. You drop it right into the shared Google Drive, and you do that 15 minutes before, 15 minutes after you conclude the test. That's your time frame for which I am accepting it. So it's good that you know how to expedite this process for submitting it to me through the shared Google Drive folder. And this also gives you an idea of what type of questions you can study for. So as you can see, problem 16, I think it's clear that there's going to be a linear programming problem on here. They do give you a graph template. It's not labeled, but they do give you a template here. 15, they give you the cryptography stuff. So you can imagine there's going to be a cryptography, either an encoding or a decoding. Encoding or decoding problem. Looks like it's going to be decoded, so even easier. Looks like there's going to be two graphing inequality problems. So you can use these, or you can use this answer sheet as a way to really specify which questions you might really want to know. But yeah, go ahead and print that out, write that down, have that ready for the final. And so besides for that, if you haven't signed up for the final, you absolutely have to do that by today. If you haven't tested your equipment, you definitely need to do that today. The reason I emphasize testing your equipment is because if you do it at the last minute, you might realize that you have some technical issue that ProctorU will not like. For example, apparently ProctorU cares about what your monitor size is. I didn't even know that was a thing. I had no idea. ProctorU is very picky. So it's good to find out now so you can have a week to prepare, maybe borrow someone's computer or otherwise, before you have this issue at the last minute. And there's minimal, there's not much I can do. ProctorU is a third-party thing. I can't do much about it. Besides for that, so hopefully you are all aware of the conditions of the final exam as well. The final exam is through ProctorU, which means you take the test in your room, wherever you take the test at your mom's, dad's house, whatever, and you take it in an isolated room. Don't have anybody around you, so taking it maybe in a public library may not be good, because if someone walks behind you, the proctor's most likely going to stop the test and ask for you to clear the room or go somewhere else. They're going to ask you to take your webcam. They're going to ask you to take your webcam and move it around and scan everything. And so, they record you while you're doing it. I know it's kind of weird, but that's, what you have to do for this class. And so again, once you're done with the test, you submit the scratch paper that you wrote down to me using the shared Google Drive, and then you're done. So hopefully those conditions are clear. And if not, it'd be better to ask me sooner rather than later when there's less I may be able to help with. So this is stuff you need to figure out now. So hopefully all of those conditions are clear. And if there's something that is not clear, you need to go ahead and, well, the best case would be to ask me now. But additionally, just a reminder to, there's the quiz tonight. So there's the quiz tonight. That one's probably going to take a little bit of time because those problems take a while. You might also notice the final exam prep quizzes. These are less important. I mean, they are for a grade. I had a few emails about that. The final exam prep quizzes are for a grade. But these are just, as you can see, they're problems that just ask you about conditions of the test. Which of the following web browsers, Chrome and Firefox? It's just asked, it's something you can get through with in no time. So you can knock that out in 5 minutes. It's just a quick point. So just do those so you can, bump your quiz grade up if you need to. But besides for that, conditions about the test, please print out or write down the final exam answer sheet and make sure you've signed up for the test. Does anyone have any questions before we move on to the practice test? If not, you can ask me after class. That's perfectly fine. So you may notice the practice exam is down here. I recommend you go through it more times the merrier. But we're going to go through this and do as many problems as possible in the time frame. So it looks like it saved my results from my last class. That's pretty interesting. Yeah, it saved my results from the last class. All right, well, let's submit this and just start over. Okay. It's going to start off with this one. Okay. So it might be good to familiarize yourself with the statistical analysis steps in the calculator. So as this implies, you might want to go ahead and pull out your calculator and make sure you can type these values in to determine the median, and it also tells you the mean and everything. So this is a process you will need to know how to do for the test. So the statistical implementation. So I'm going to go ahead and start typing all these numbers into the calculator now. 831, 28. So it's not a very fun problem, but okay. Seems like I do have 46 entries plugged in. And whenever I apply the one variable statistics to it, I get 45.5 for the median. Now I may have typed that in wrong. If I did, just at some point let me know, because that is 46 entries. We're all subject to error. I do type them in kind of fast, so. Okay. So I found that the median was 45.5, provided I typed in everything correctly. And from there, we can move on to the quartiles, which the calculator also provides for us. The first quartile is 37. The third quartile is 55. And then from there, they want us to find the fences, in particular, the upper and the lower fence. So hopefully you remember that the lower fence, actually, I'm getting ahead of myself. To figure out the fences, you need the interquartile range, which is the difference between the two quartiles. So that's 55 minus 37. We just found those. What is that, 18? And now from here, we can figure out the lower fence, which is Q1 minus 1.5 times the interquartile range. So that's 37 minus 1.5 times 18. So we get 10. The upper fence is Q3 plus 1.5 times IQR. So it's 55 plus 1.5 times 18. Which is 82. So we found that the lower fence is 10, the upper fence is 82. And we need to figure out which answer choice we select. Because there's 4 various options, and they continue to ask about outliers. So they're asking, do any of these values fall lower than 10 or higher than 82? We can actually use the results of the calculator to give us a very expedited answer. Because the calculator in the statistical analysis, it tells us that the minimum data point is 21 and the maximum is 73. So that tells us that all of our values will fall within the fences. So I'm going to pick answer choice C. So the upper fence is 82 and the lower fence is 10. And I'm selecting the one that says none of them fall outside the fences instead of inside the fences. Because outside the fence would be outliers. But none of them fall outside of the fence. Everything is within the fences. So from here, we can go ahead and also construct a box plot. So the box plot is an order of, well, it's an order relative to the 5-number summary, which it'll actually be easier to put the 5-number summary first and then match the box plot with it. So it's the minimum. In fact, they're in order in your calculator. It's the minimum, then Q1, then the median, then the third quartile, and then the maximum. You go in order in your calculator. And from there, the box plot, each column, each vertical line in your box plot represents the 5-number summary in order. So the first line needs to match up with 21. This one does not. This one looks like it does. This one looks like it does. And this one does not. So these two are out. It seems like the maximums are good. So what about the median? That's my next question. So the median was 45.5. So that's 40, 45, and 50. So this one has an incorrect median. It has to be answer choice D, because each vertical line needs to match up. And so we can figure that out using process of elimination. Okay. And then finally, it's this last problem down here. In the championship game, teams typically score. So a typical score would be the median. So that's 45.5. And then with half of the games totaling more than the first quartile, because remember the quartiles, the first and the third quartile represent the inner 50% of the data. So the first quartile, but less than the third quartile. That's where half of the expected values are occurring in. And only 1/4 of the games have the team score fewer than the first quartile again. It's from the first quartile to the lowest value, which is 21. That's a 25% step, or in other words, 1/4. And then the most the teams ever totaled was, well, the maximum, 73. So you might think there's 5 choices and there's 5 numbers and it acts as a word bank, but we actually use one of these values twice. Okay, so the main importance is definitely to know how to do the statistical analysis in your calculator. Definitely need to know that. We're going to go ahead and move on so we can do more problems. Okay, and now we have a linear equation. X over 6 plus 1 over 2 is equal to 5 over 12. And hopefully you remember how to do these, because this one should be one you can knock out and go on to the next question. So what we did, we solved fractions. We applied the least common denominator. Least common denominator is the smallest number that all the denominators go into. Here it's going to be 12. Because 6 goes into 12, 2 goes into 12, and 12 goes into 12. And the reason why that's helpful is because once we multiply the least common denominator to every term, it's this interaction here that's going to clear the denominators, which is great. We want to clear the denominators. So 12 divided by 6 is 2. 12 divided by 2 is 6. 12 divided by 12 is 1. So now we get what's left over. 2x. So 2x plus 1 times 6. Just 6, is equal to 5 times 1. It's just 5. And notice how much more simplistic that looks. In fact, we can do that. We can go from here pretty easily. Subtract 6 on both sides. It's -1, and so x is -1/2. So x is -1/2. have. And if there's an issue on your test where, let's say you put the answer as negative 0.5, and for some reason my math lab, being picky as it is, marks that wrong, I'll just go back in and make it right. You know, I can grade for partial credit, and that's an easy one. I could just give you your points back. So don't worry about formatting too much. I can go back in and, you know, give you the points back for those. So if you were wondering how to format it. So let's move on to another problem. Okay, this is more conceptual. Which single measure of central tendency, mean, median, or mode, best describes the following set of measurements, and they give us a table of values on the right. So here, well, normally the mode is normally a terrible measure of central tendency, so we'll ignore the mode. So it's either the mean or the median. Well, the mean is normally good unless there's outliers. Wait a minute, I see an outlier, a very egregious outlier, the 85.5. That's way larger than the other values. So the mean is 100% going to be skewed. So if anything, the median will be the best measure of central tendency. The median is, if you have me for statistics next semester, you'll hear me say this again, but the median is a quantitative measurement, which means it only cares about the number of data points rather than the quality of the data points. So the median is not affected by the outlier. So that's the answer choice I want to pick. The median, so the main bullet points here, the median is not affected by the outlier. So that's more of a conceptual problem. So if one of those comes up, hopefully you can knock it out pretty quickly. So basically the mean is not affected by the outlier. This one should also be another quick one. Write the coefficient matrix and the augmented matrix. What does a coefficient mean? A coefficient is just number in front of variable. Numbers in front of variables, we have 4 of them. Notice that those 7s are not in front of variables, so they're not coefficients. So they put 6 for us, so I'll continue with 3, 5, and -6. And then for the augmented matrix, now they want us to throw those 7s in. So 5 down here, 3 up here, -6 here, 7, and 7. So that one should be pretty straightforward. It's just rewriting the system as various types of matrices. That's all you really do for this one. So I'll go ahead and move past this one. Okay. So we have a problem here. So really they take a lot of this information and put it into a table for us. There is a little bit more information in the paragraph, but in reference to the matrix A, so it says, write the information in the table as a matrix A. Okay, that sounds pretty straightforward. We can do that. So notice down here, there's a matrix tool, which hopefully you are acclimated with. We're rewriting the table exactly. So 2 rows and 2 columns. That works out perfectly because we have 31, 40, 43, and 60. I'm rewriting the table as a matrix. And if you want to, you can go ahead and start putting that in your calculator if you haven't seen that already. All right, so what about this matrix Q? That's the next question. What does it say about Q? Matrix Q of the appropriate size, we'll get to that later, containing the quantity of each type. So the quantity of each type, they actually explained that in the sentence before. 5 and 7. That's the quantity of each type. 5 economy models, 7 deluxe models. So the matrix Q can either be 5 and 7, because those are the only two numbers they give us, or it could be 5 and 7. And you might think, well, who cares? They look like the same to me. Well, the appropriate size that they're referring to is we need to multiply this matrix Q to A. We're multiplying A times Q in the next part. One of those sizes is not going to work. And we see that matrix A is a 2 by 2 matrix. So that means for Q, we need to pick Q such that these two numbers equal. Well, if those two numbers equal, then this obviously has to be 2. So that forces Q, so the appropriate size here is that Q has to have 2 rows. That's this one, and not this one. So the matrix, so it's 2 rows and 1 column, simply 5 and 7. Oops, 5 and 7. So that's the thought process here. And the only reason we formatted it as a column matrix instead of a row matrix was so that the next step will actually make sense. So from here, they immediately want the product A times Q. So they want the product here. So this is when plugging each one of these matrices in your calculator will be helpful. So I'll go ahead and do these right fast. 3140, 4360. Next one is a 1 by 2, or 2 by 1, sorry. 2 by 1, it's 5 and 7. A times B is, so I get 2 rows and 1 column, 435 and 635. That's what I get for the product. All I did was put that in the calculator. So that might be something you want to make sure you know how to do, because you will need to know how to, do various matrix operations in your calculator. So it may be good to acclimate yourself with that process. And so the entries, they want us to select all that apply. So because our matrix Q had 5 for the economy models and 7 for the deluxe models, this actually tells us the total cost of labor. And actually, let me make sure of that. So 5 times, for the economy models, that's, let me make sure this is right. $31 times 5, 40 times 7. No, so it is the other two. Okay. So it's the other two by the virtue of how that matrix Q multiplies the matrix A. So it's very clever. Okay, so it tells us the total cost of materials and labor, respectively. because that is ultimately, this is the matrix on the right. So it tells us both of that information simultaneously. Okay. So let's go ahead and look at another problem. Okay. As we can see from the words mean and median, this is a statistics-based problem. So we should adjust our mindset as such. The mean wage and the median wage. So you can actually plug these in your calculator to figure out the statistical analysis. But the way you put it in your calculator, this one's a little bit of a tricky problem, because if you were to type all of these in your calculator, so there's a supervisor at 1,300, inventory manager at 850, and 6 stock boys at 400. So normally people will put the quantity 400 one time. You actually have to put 400 6 times. 4, 5, 6. So if you type this in your calculator, you need to put 400 6 times. And then 4 drivers at 550 a week. So then you have to put 550 4 times. 1, 2, 3, 4. And that's what you would list in your calculator, which I'm going to go ahead and do that right fast. Oops. 1,300, 850, 400, 400 again, 4, 5, 6, 1, 2, 3, and 4. And if you put everything in your calculator correctly, the mean wage is 562.5. That's the first one, the first quantity, provided I typed in everything correctly. If I didn't, just let me know. Or if you got something different, let me know. So, and then the median, I get 475. And then they want us to determine which one of these is the best measure of the center. So really, it's a toss-up between the mean and the median. And that's based off of if we have any outliers or not. If we have an outlier, the mean's not very good to use. If we don't have any outliers, the mean's perfect to use. So we do have an outlier because, well, out of all these values, I mean, if anything, this looks like a huge outlier in comparison to all the, I guess, the salary of the stock boys and the drivers. So if anything, there is an outlier. And in fact, the description goes on to say that both of these are outliers, which in any case is just the presence of a single outlier that tells us that the median is going to be the best measure. And so answer choice C seems to be the better answer between that and A. C and A both assert that the median's the best, but we need to emphasize that the mean is not good because it is affected by the outliers, i.e. the 2 higher salaries. So that's the better description to really encapsulate the inefficiency of the mean in determining the center. Okay, let's move on. All right, so we have something from Yin 4. Graph the inequality. So let's go ahead and use the techniques that we've talked about. So if they asked you to do this on a test, as you saw from the answer key, there is some part that they want you to fill in on your own. So in particular, what I'm referring to. So as I mentioned in the very beginning, they have these graphs here. So they may expect you to do all of this by hand in addition to doing it online, or maybe they might just have you do it by hand. So that's just something to keep in mind. What you got?
What's those lines?
The lines.
It says rewrite your inequality here. Would that just be the
Yeah, you would just say like 2x plus 3y is less than or equal to 6 or whatever it tells you. Yeah. So let's go ahead and go back to the problem. So the way we normally graph these, so generally we find the x and the y intercepts. And it seems to be that the x-intercept here, you set y equal to 0 and you solve for x, you get that x is 3. And you get that y is 2. And so once you figure out the x and the y-intercept, well, we can go ahead and plot those points. But I guess before I do so, I want to make it clear that we get a solid line as well. We're going to have a solid line because we have an equal to part in our inequality. So the x-intercept goes here, the y-intercept goes there, the line is solid. I'll save that while we think about the shading criteria. So do we shade below the line or above the line is the question. And so for this, we need to test the origin. When we test the origin, if we get a true statement, we shade on the side of the origin. If we get a false statement, we shade away from the origin. So let's test 0, 0. So 2 times 0 plus 3 times 0 is less than or equal to 6. That's the original inequality. And so that gives us 0 is less than or equal to 6, which is a true statement. So because we get a true statement, we shade on the side of the origin. So click the bucket tool. And we shade on the side of the origin, just like that. And so just keep in mind, you might have to recreate this illustration on your paper as well. Or you might not have to. I mean, to be honest, I don't write the test, so I don't know what it looks like yet, to be honest. Okay. So maybe expect a problem or two of that caliber on your test. Be safe to say. Maybe an easier one and then a more complex one. I'm going to skip this one so we can look at other ones. That's just linear equation. Let's do something like this. Something that's a little bit further removed. All right, they tell us that there is a normal distribution with mean 100 and standard deviation 10. Find the number of standard deviations the measurement is from the mean. So it'd be good to know how to dissect this information without being given any resources. So you don't have the formulas in front of you. How do you determine well, in particular, the number of standard deviations the measurement is from the mean? And they tell us we're trying to figure that out for 66. So the formula for that, 66, well, we need to subtract off the mean and divide that by the standard deviation. So This is negative 34 divided by 10, which is negative 3.4. So this is a formula that I talked about in class. So it's the number minus the mean divided by the standard deviation. And really, technically, this is the z-score. But they also say, and I think I missed this at one point when I did a practice test weeks ago, express the answer as a positive number. So they kind of throw in that detail at the end. Now, if you put in the negative number, I go back in and I give you most of your points back, and I take off maybe 1 point. It's not a big deal. So we got negative 3.4, I put in positive 3.4. We just want the positive. They want the magnitude, in other words. So that's my modification. So again, knowing a formula like that is helpful. And you get as much help on your test as that answer key provides. So it may be good to keep in mind that there are formulas that may not be present on your test that you need to know, this being one of them. So let's go ahead and move on. Okay, so with this problem, we're going to find the labor cost for a one-person boat manufactured at State A plant. So the interesting thing about this problem, I know I did this problem in my notes. And yeah, I should probably do it again. When I did this in my notes, I noticed that, so I did it in my notes with the last 2 parts switched from the first 2 parts, because you need to know what the matrix is in order to answer parts A and B. The problem with this is you need to figure out how to multiply these matrices together. So really, I'm going to skip parts A and B, because really the later parts help us determine the former parts. So whoever made this problem, they really should have put A and B last, in my opinion. So I'm going to start at part C here. So what I'm going to do first, I'm going to make this matrix A in my calculator. I'm going to make this one matrix B in my calculator. I'm going to go ahead and do that right fast. So first one is a 3x2 matrix. 16.94, 13.63, 12.74, 16.18, 11.24, 11.15. And then I'll go ahead and put in matrix B. It's a 3x3 matrix. 0.6, 0.4, 0.5, 0.8, 0.5, 0.6, 1.5, 0.9. Okay, so I'm going to multiply A and B together in my calculator. And I get an error. So in other words, when I multiply N and M together, there's an error. So what about if I switch up the order? If I put B first and then A in my calculator? Then that actually gives me an answer. So that goes down to this interpretation here. So the matrix product MN exists and represents total labor, let me make sure I select the right one. These are always a little tricky with the labels. It represents the, let's see if M goes on the left here, it's going to be for each boat. Yeah, it has to be this one. Okay. So normally the matrix, the rows on the left matrix pretty much tell you the accumulated values. And as we just determined, NM is an error. Multiplying them in that order does not exist. And so if MN is meaningful, let's go ahead and write its product down. So one easy way to determine which one that we fill in is that there's one-person boats, two-person boats, four-person boats, but the top matrix only has 1 and 2 person. As for matrix B, which has all 3 of them, 1, 2, and 4 person. And so my calculator gives me 20.88, 20 and I believe there's a part that says round to the nearest cent. So 23, 26.67, 25.68, 44.47, 46.57. To be honest, I don't expect this to be a problem on the exam. But we also said NM cannot be determined. And then from here, one-person boat in state A is 20.88. So one-person boat in state A, that's why I put 20.88. Four-person boat in state B, four-person boat, state B, it's 46.57. Let's keep going. And this should be a quick one. They give us 2 matrices and they ask us to add them together. You should be able to identify right away this addition is not possible. Because with addition and subtraction of matrices, the sizes have to be the exact same. Matrix E doesn't have as many columns as matrix B. So therefore, you cannot add these 2 matrices together. It's not defined. All right, so this one's a more expected problem on the test. They could ask something like this. X minus 4y is greater than or equal to -8. 3x plus y is less than or equal to 6. So we're going to, like we did in the programming section, just about, we're going to go ahead and find the intercepts. The x-intercept is x is equal to -8. Y-intercept seems to be y is equal to, it's like +2. Over here, you can find the x-intercept of the second inequality. The x-intercept, x is 2, y is 6. And hopefully it's clear that these are both solid lines. They're both solid because both of the inequalities have equal to parts. So let's go ahead and plot all of these. So the x-intercept is -8 and the y-intercept is +2. And then for the other line, the x-intercept is 2 and the y-intercept is 6. If anything, I'll save that for now. Now I'll make a little point of note here, which line is which, as I consider now which region to shade. So in both cases, I will be testing the origin, which will tell me which region should I shade. So I'll test it for the blue line or the first line. So for the first line, when we test 0, 0, the inequality now says that 0 minus 4 times 0 is greater than or equal to -8. Oops. -8. And so ultimately that 0 is greater than or equal to -8, which is a true statement. So what that tells us, for the blue line, or the first line we drew, we will shade towards the origin. So for the blue line, we shade towards the origin. So far, this is the shaded region that we get. Now we're not done, but this is what this tells us so far. We just split the number of options in half. And now the red line will tell us whether we shade closest to the origin for that corresponding or away from the origin. So we're going to test 0, 0 for the red line. And so this is 3 times 0 plus 0 is less than or equal to 6, or in other words, 0 is less than or equal to 6, which is true. So this tells us for the red line, or the second line, that we shade towards the origin, which means that only this region here at the bottom is the region that we end up ultimately shading. Let's go ahead and shade that in and be done with this problem. So reshade this region. So I feel like that would be a fairly typical problem to expect on the test for an easier type in comparison to the system that has a lot more with the non-negative restrictions and whatnot. Okay, let's keep going. So this is solve the system of equations by graphing. Now, one thing I did want to note is that, so I'm going to detour right fast. On the final exam answer sheet, problem 9 says solve by hand using substitution or elimination by addition. So as that implies, you will need to know how to do one of those, it doesn't matter which one, by hand. You can use the matrix method to test or to check your work, but you will ultimately need to show some of the steps behind the substitution or elimination method. So I just wanted to say that. So again, it might be good to go over the answer sheet here and make sure you familiarize yourself with any clues that this might tell you for things you should expect. For here, we're going to solve the system of equations. So it's not a system of inequalities. It's a system of equations. We're going to solve this. And they tell us to do it by graphing. 4x minus y is equal to 8. And x plus 2y is equal to 2. And so why this is convenient is because we still treat it as if it were a problem before. We still find the x and the y-intercept. X is 2. And Y is actually going to be -8. So Y is -8. So not +8, -8. Because it's negative Y is equal to 8. So then Y is -8. And then over here, the x-intercept is X is 2. The y-intercept, you end up getting that Y is 1. So the x-intercept is 2, the y-intercept is -8. The x-intercept is 2 again. Oh, well, that actually answers it for us. These go by, looks like halves. So I think it's pretty clear that the point of intersection is just negative, or it's x is equal to 2. Or in other words, is an ordered pair, it's just 2, 0. It's the exact point for which the two lines intersect. So this is solving by graphing. And so the versatility of this is that if the graph works out very nicely, you could just tell by looking at the grid lines and seeing where the point of intersection lies. Okay, let's keep going. Okay, so you can go ahead and look at this problem. In fact, before I do this problem, there's a problem similar to this. Oh, well, this problem, this is a busted problem. I spent like 5 minutes in the last class figuring that out. If you see this problem when you do the practice test, this is a busted problem. And the reason why, it says find the test scores, but then it asks for the percent of students. That's not the same thing. So this is a busted problem. Just don't worry about this one. So, because these are generally a little bit cumbersome to do. But this has to do, I believe what they're asking for is, because it's normally distributed, it's that 68, 95, 99.7 rule. And then you have to use the fact that A is 2 standard deviations above. Yeah, it doesn't matter. It's just a busted problem. Normally, you're not asked to find percentages without a graph. So if you see something like that, it's a busted problem. But this problem, as soon as it loads, okay, this problem is okay. It almost looks the exact same, but it says find the test scores, and then it actually asks for you to find the test scores. So don't get too bogged down if you see that. So that other one's a busted problem. So we're going to find the test scores for, so what test score or scores would give someone an A with this implemented curve in place? So for A, it says that you have to have a z-score greater than 2. So how do you find the z-score greater than 2? So the formula, well, in general, I'll just write it over here. The z-score, you take the, really it's the mean or the average minus the score itself times the standard deviation. So really, this is the formula we will be utilizing the whole time. So if we're looking for a z-score of 2, well, the mean is 70, because they tell us right here. I don't know why I have minus. It should be plus. Sorry, it should be plus. I don't know why I have minus. So plus 2, because the z-score we're looking for is 2 above the mean, times the standard deviation, which they tell us is 5. So really they're telling us to add the standard deviation twice to the mean, and that's 80. And it's just 80. Okay. So it's 80. 80 or greater. So notice I'm putting the or greater. It's not between, because in A grade, there's only a lower bound for it. The upper bound, that's kind of understood. So it's a very generous curve. So an 80 or greater would result in an A in this class. So the next one, find the test score to receive a B. And so we do the same idea. Now we already know one of the answers. The highest grade to get a B has to be the lowest grade to give an A. So we already know the upper bound of the B grade. It's 80. Because it's between whatever the lower grade is and 80, and then as soon as you exceed 80, you're in the A range. So we know the upper bound. So all we have to do is figure out a z-score of 1. So the formula tells us we plug in 1 instead of 2, which tells us that it's 75. So a B grade is between 75 and 80. And so from here, now we can go ahead and figure out the C grade, or the range to get a C. And we know the upper bound is 75. Once you exceed the upper bound for a C, then you go right into a B grade. So for C, all we have to do is figure out the lower bound now, which seems to be -1. So Z of -1. 71, or that's 70 plus -1 times 5. So really we're subtracting 1 standard deviation from the mean to get 65. And so the lower bound then is 65, which tells us the upper bound for a D grade, 65. Lower bound for a C is 65, which means the upper bound for a D grade is 65. And then finally for the D grade, we just need to figure out the lower bound, which is a z-score of -2 plus -2 times 5. So we're just subtracting 10, which is 60. Is the lower bound, and then everything lower than a 60, well, guess what? That's an F. These are actual ways in which grad school curves test. You'd have the highest grade in the class being, say, a 75, and that would be an A because of the curve. Happens more often than you think. Also, interestingly enough, a little off topic, if you get a C in grad school, they generally kick you out. So you can't get C's in grad school, or they kick you out. found that to be pretty interesting, the condition. But in any case, yeah, that's the answer here. All right, so let's look at another problem. So this is the busted problem. Again, yeah, don't focus on this one too much. If it asks you to find the percentage of students without a graph, you're not expected to do that. They normally give you some sort of aid. Okay, here's a box plot problem. And so hopefully, in fact, the first problem we looked at contained a box plot. So remember, the box plot is part of the 5-number summary. So it would be the minimum value and the first quartile, and then the little dash in the box is the median. And then the end of the box is the third quartile, and then the very end is the max. And then additionally, the dots are outliers. So what they want us to do first is list the regions from lowest to highest in terms of the median. Lowest to highest in terms of the median. So remember, the median refers to the inner dash in each box. So really, we are ranking these from lowest to highest in terms of those dashes in order. So it looks like the first one is region B. That one's all the way to the left. And then the next one seems to be region D, followed by A, and then C. So that's ranking them by median alone. For part B, it wants to know which region has the largest interquartile range. Remember, the interquartile range is the difference between the quartiles. So that's the beginning of the box to the end of the box. So really, what this says, which has the largest box. So that's all it's asking for. Which one has the largest box? And so that's obviously choice C. And then which one has the smallest box? A, the one at the very top. And then which region has potential outliers? That's where those dots come into play. So that's region B. And so it asks for one more interpretive thing at the bottom. And then it wants to know, well, it words this as an interpretive thing. So it's asking, why is 24 considered an outlier for one, but then 24.5 is not an outlier for another one? And it sounds like it's more engaged than it is, but then it starts to ask you for what the definition of the fences are, which help you determine outliers. So hopefully you remember the formulas for the lower fence, which I wrote before. And I'll just leave it at that because this tells us that the multiplier is 1.5 because it's right here in the formula, below the first quartile or above the third quartile. So really it's just asking for the definition of the fences. So really it doesn't ask you to do anything more engaged than define the definition of the upper and lower fences. So there. What was the answer for the grade? I'm sorry, I'm just now seeing that. What was the answer for the grade of A? So to answer your question from before, it was 80 or greater for A, 80 or greater. So 80 or greater for A. So maybe I can do a few more here. Okay, this one's definitely good to do because when I showed the scratch work earlier, or the answer key that you will print out, there was one on there that seemed like it alluded towards a decoding problem. That's what it looked like to me. So this is a good one to know how to do. And so we're trying to decode this message. And so decoding the message, if anything, decoding means you need a inverse. Don't forget, you need the inverse to decode. I guarantee there's going to be some of you on the test that will use A, and you will wonder why all of your numbers are coming out so weird. So your final answer should have numbers that convert nicely to letters because you're decoding, you're trying to figure out what the message is. So what I think is the easiest way to do this, as I mentioned when I talked about cryptography, is in your calculator, of course, let A equal 1213. You can worry about the inverse later. And then matrix B is going to be the coded message. Now remember, it needs to have 2 rows so we can actually multiply this to matrix A. So I'm writing down the numbers in order, 40 and 55, but I have to keep it at 2 rows, so I'm going to keep looping around. We're just starting over on a new column. 44, 66, 43, 57, 28, 42, 47, 68, 15, 16, 42, 56. So I'm going to go ahead and put those 2 matrices into the calculator right fast. 1, 2, 1, 3. And then the other matrix, 4, 8, it looks like a 2 by 8 matrix. 40, 36, 44, 43, 28, 47, 15, 42. Okay. So in the calculator, you want to make sure you put this in correctly. A inverse B is what you should have, because you have the inverse to decode the message. So I'm going to type in A, then make sure I press the inverse button, and then B. I plugged in matrix B for matrix A. I can fix that though. So if I do it that way, okay, 1 second. That inverse and then that should fix it. Okay, cool. So what I get, I'm not going to write down the matrix. I'm just going to write down the numbers that I get. So if you put this in your calculator correctly, you should get 10, 15, 8, 14, 0, 22, 15, 14, 0, 14, 5, 21, 13, 1, 14, 14. So as soon as we figure out what this word is, we can call it a day. So if anyone's figured it out, you could tell me now. Other than that, I'm going to have to pull up this thing. All right, so 10 is J, 15 is O, 8, John, and then there's a space, V, O, and then it looks like 14, 14, 0, 14. So N is 14. So that means N, 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 A, So what is that? That's 5/21/13. 5/21/13. What's that? So 5 is 21, even 13. Okay, that took a little bit longer than I expected. But that's the answer, and that's all the time I have. So if you have any questions, I'll stick around for a few minutes. But other than that, that's all I have for this class, and I will leave you to your own devices. Yeah, have a good day.